Of lesson 5.1. So we're working on this chart here, determining which of the two variables are the independent and dependent variable. So like I said before, when you have time is always going to be your independent variable. So our first one says distance traveled and time. Our independent variable will be the time. Dependent variable, distance traveled. Okay. Next, time of the year and cost of a vacation. So again, time of the year, that's time. So it's a time period, so it's going to be the independent variable. Time of the year, cost of vacation. I'm just going to put cost right here. Okay, that's the cost of the vacation. C, a person's height and their age. So it doesn't say time anywhere here, but we know that age would be considered a time period, right? So the independent here would be age. Okay, we already saw this example on our graph before. Okay, so age would be independent and the height would be dependent because it depends on their age to determine how tall they are. Number of hours of work and pay. So we have another time period, number of hours. So our independent will be number of hours, and dependent will be pay because it's dependent because the pay is dependent on how many hours are worked. Okay. Example 2. What was the approximate temperature at a depth of 40 meters? So we're going to have to look at our graph here. We'll zoom in a bit. So we have to look at 40 meters. So we see 40 meters here. What's the approximate temperature? So it means a little higher than 27. We can say 27.1. We can say 27. It's saying approximate. So we just have to give something close. So I'm just going to put 27 degrees Celsius because normally when you hear the temperature, you hear it's 27. You don't hear it's 27.2 degrees. Okay, next question. What depth is the temperature a little more than 26? So we look at our graph. We see a few are a little more than 26 right here, right? We see 26. There's a few dots. So we can say between the depths of 50 meters, right? Because 50 meters, 60 meters, and 70 looks all just above. So we can say between 50 meters and 70 meters. Do the points on the scatter plot show a relationship? If so, what type of relationship? So we can see it starts at the top and it's moving downwards. We see kind of a relationship here. Which type would it be? We're going to say a downward trend. And it says explain as well. So I'll explain why. Okay, because as it moves to the right, our dots are also moving downward. So we call that downward trend. Next, the scatter plot below shows the number of goals scored versus the shots on goal by different members of a soccer team during the course of a season. So each dot on our graph is going to be a different player on the team. As we move further right, that's the amount of shots on goal. As we move up, that's more goals scored. So now we have to pick a sentence from here that describes it best. So what's the first one say? There is no relationship between shots on goal and the number of goals scored. Okay, we can see there's a relationship, right? As it moves to the right, it's also moving upwards. Okay, the number of goals scored decreases as the number of shots on goal increases. If we look at our graph, we can tell that's not true because as the amount of goals scored or shots on goal increase, so do the goals scored. Okay, so let's read the third one. The number of goals scored increases as the number of shots on goal increases. Okay, so we know this one is right because as we get more shots on goal, there's also more goals scored. Okay, moving to the last question from this unit, or this lesson, 5.1. Okay, the graph shows, let me zoom in to this one. the graph shows the shoe sizes of girls of various heights. Okay, so our x-axis has our height and our y-axis has shoe size. Okay, so we can see a upward trend here. The taller someone is, the larger their shoe size. Okay, now our question is asking us, which point out of W, X, Y, and Z represents a girl whose shoe size is smaller than expected for a girl of her height? So we're looking for an outlier here. We see there's basically two outliers, Y and X, but it's looking for someone whose shoe size is smaller than expected. So we want someone who's lower on the graph than expected. It would be X here. Because this is where it's expected the shoe size to be someone this height, but X is, shoe size is a lot less. So it would be X here. Next question. So this graph represents the relationship between the number of calories and the volume of various drinks. Okay, so we have volume in our x-axis, number of calories in the y-axis. So normally, the more liquid in a drink, the bigger the drink, the more calories it's going to have. Okay, that's what the relationship shows here. But our question is, which of the following points of P, Q, R, and T represent a drink with more calories than expected for its volume? So we want to find one whose point is a lot higher than expected. So this is our upward trend. We see Q is a lot higher than it's expected. So it's expected to be around here, but Q is all the way up here. So our point Q is the one that represents more calories than expected. Okay, hopefully this lesson made sense. Let me know if you have any questions.